welcome to this explainer. Okay, so today we're looking at something that honestly might sound a little dry at first glance, but it is absolutely crucial in Web3 development. We're talking about establishing pre-deployment checklists on Solana. Now, I want you to literally banish the idea of a checklist as just, bureaucratic paperwork or some dusty PDF of manual to-dos. What we are really building here is an engineering blueprint. It's a formalized, automated mechanism designed specifically to prevent catastrophic mainnet failures before they ever even happen.
Okay, let's dive straight into this. Here is our table of contents for drafting this master deployment mechanism. First, why we actually need checklists. Then, the anatomy of a check, building the YAML blueprint, automating with CI pipelines, and finally, monitoring and risk mitigation.
Section 1. Why we need checklists. Moving beyond the big red button.
Look, we've all been tempted to just mash that giant big red deployment button, right? But deploying on Solana without a safety schema is honestly like flying a jet blindfolded. You might take off, but man, the landing is going to be incredibly messy. Instead, take a look at the dark green text right here. I really want to emphasize that word codified. A pre-deployment checklist is a codified sequence of verifiable checks that absolutely must pass before any Solana program release. So we're shifting our mindset completely away from manual human-driven checklists. We aren't just checking off items with a pen anymore. We're writing machine-readable rules that automatically enforce our risk management policies.
So what exactly goes into this blueprint? Well, these orange bullet points outline the exact mechanical components of our diagram. First up, environment sanity. Like, are we absolutely sure we're pointing at mainnet and not devnet? Then dependency verification, which ensures we're using the right binary hashes. Access control verification checks our secret rotation and deployment keys. Next, resource budget estimates, and this one is uniquely crucial on Solana to make sure things like rent-exempt balances and account limits aren't exceeded. And lastly, observability hooks. These just make sure we can actually monitor the program once it goes live.
Section 2. Anatomy of a check. Designing the mechanism. Now that we've got the broad categories down, we need to zoom in and look at the atomic structure of a single check. And this brilliantly illustrates how every single check must be atomic. That just means it can run entirely on its own, which makes parallel execution way easier later on. So step 1, you define a stable ID, something like sanity. 2, write a human description so your reviewers actually know what's happening. 3, set the severity level. Basically, does a failure completely stop the deployment or just trigger a warning? And step 4, you've got to assign a team owner because, let's be real here, assigning an owner dictates exactly whose pager goes off at 3 a.m. if things break. And accountability, that is the absolute ultimate feature in risk management.
Section 3. Building the YAML blueprint. Drafting the machine code.
Okay, so this is where we actually translate those atomic concepts into our ultimate source of truth. We use YAML for this because it's super compact and, well, universally supported by CI tooling. Right at the top of our sketch document here, notice that dark green text declaring version 1.0. You should always include a schema version right up front. Declaring this version means your future tooling can actually evolve. As your engineering team scales up and you need to add new fields, you can conditionally parse them without completely breaking all your existing CI parsers. It's a real game changer.
Now, what's really interesting about this slide is seeing how these atomic components actually come together in the YAML sketch. We've got our ID, our severity, and our owner. But the real magic happens right there in the automated _command field. It points directly to an idempotent script that the CI runner is going to execute. And a quick, absolutely crucial tip here. Keep these scripts short, make sure they can be run multiple times safely, and please make sure they are completely free of inline secrets. Your YAML blueprint should literally never contain private keys.
So let's contrast that high-severity environment check with this one here, account limits. You'll notice this one has a medium severity. And this is just a perfect illustration of risk management policy in action. A high-severity check failing is going to hard block a deployment, no questions asked. But a medium-severity failure, like on an account limit check, that might just trigger a quick Slack warning to the DevOps team, basically saying, hey, rent accept balance estimates are running a bit high, but it won't necessarily stop the entire release dead in its tracks.
Section 4. Automating with CI pipelines. Powering the blueprint.
All right, now we take this static file and we plug it right into the beating heart of our automated CI machine. And the true beauty of this YAML structure is how perfectly it balances two totally different needs. On the one hand, you have human readability. When a release engineer is reviewing a pull request, they can just quickly scan the descriptions, verify those severities, and instantly understand the intent. But on the other hand, you have machine enforcement. Because let's face it, CI systems don't care about your intent, they only care about strict, unforgiving logic. They can easily parse that YAML array to execute all those automated commands in parallel.
Let's actually move to and see how this builds out in a real workflow. Step 1, an engineer merges their code to the release branch. Step 2 is absolutely vital. You run a basic linter script to validate the YAML structure itself. You've got to reject incomplete checklist definitions, like say a missing owner or some invalid severity level, long before the CI even attempts to execute the commands. Now, if the linter passes, Step 3 kicks in, and the CI executes all those automated scripts. And finally, Step 4, the pipeline will either block the release entirely or just issue warnings, all based on what those scripts return.
Section 5. Monitoring and risk mitigation. Closing the loop.
So the crucial point here is that it's just not enough to check things before deployment. We actually have to ensure those assumptions hold true in production on mainnet. This sketch table illustrates exactly how we connect our pre-flight checks directly to runtime observability. Inside our YAML, we can literally add a monitoring signals field. So for environment sanity, the infra team monitors RPC latency. For account limits, DevOps monitors the account count and rent-exempt balances. By explicitly linking these up, your on-call teams know the exact metrics they need to be watching on their dashboards the very second a deployment goes through.
To wrap things up, I really want to leave you with this somewhat provocative question. When your linter catches a high-severity failure, or when an automated check suddenly blocks your pipeline, what exactly is your remediation playbook? Because, it's one thing to stop a bad deployment. It is a whole other beast to know how to fix it efficiently. So, I highly encourage you to start drafting your own YAML deployment blueprints today. Get those owners assigned and define those rollback strategies, for sure. Thanks so much for joining me on this explainer, and hey, happy deploying.